for the more information at our website or at the courses that is made for us. Before we start off today's program, I request you to switch off your mobile phone. So let us see that the program goes on smoothly. And to start with, I request our director, Dr. Guru Prasad sir, to address the gathering.
Thank you, Dr. Respected and many of the galaxy of dignitaries who have come here today for this lecture, and my dear students and my own colleagues. Yes, as Dr. Anil mentioned, on the occasion of the Astronomical Society of India, public occasion of India, as well as the ASI itself has organized a series of talks. We are very fortunate to be the venue of the talk, and one of them today is the most exciting one. All of you have enjoyed the landing of Chandrayaan-3 in the South Polar region of Bengaluru, 23rd August 2023 last year. So, anyway, about Indian lunar missions, today Dr. Anil Bharadwaj has come to speak to us, to give a popular lecture here, public lecture, and have the pleasant duty of introducing Dr. Anil Bharadwaj, whom I know for the past 3 decades. Okay? Let me introduce him briefly. And Dr. Anil Bharadwaj is the director of Physical Research Laboratory. With that person, Professor Anil Bharadwaj is the director of Physical Research Laboratory, Ahmedabad. All of you know the nucleus of space activities of India as early as 1962 was none other than Physical Research Laboratory, Ahmedabad. ISRO was not there at that time. ISRO came into existence only in 1969. But activities started in Physical Research Laboratory as early as 1962 under the leadership of Dr. Sarabhai. Today, that institution is headed by Professor Anil Bharadwaj. And he has a very illustrious academic and professional career. Okay? After completing his MSc from Lucknow University and PhD from Institute of Technology, IIT PhD, Banaras Hindu University, Dr. Bharadwaj joined ISRO in 1993 at Space Physics Laboratory, Vikram Sarabhai Space in various centers of ISRO we do space science in India. He was the director of Space Physics Laboratory later during 2014 to 2017. Many of the instruments are developed by that in our space science missions. More importantly, equally importantly, he worked at NASA Marshall Space Flight Center for about 2 years during 2004-2005 as NRC Senior Research Associates. Marshall Space Flight Center of NASA is one of the prominent centers where Saturn V was developed in Huntsville, Alabama. And his primary research field, it's very interesting, is planetary and space sciences and solar systems. Very exciting. He has used, in this regard, he has used Chandra Space Observatory, XML Lunar of the European Space Agency, Hubble Space Telescope, of course, and of course, our own GMRT telescope. Professor Bharadwaj was principal investigator of SARA experiment on the first Indian lunar mission Chandrayaan-1, okay? And Menka experiment on the first Indian Mars orbiter mission, popularly known as Anil. Okay, he has so extensive experience. His team have PRL experiments on Chandrayaan-2 and even on Chandrayaan-3 missions. The first Indian solar mission, Aditya L1, which is in progress, as well as the upcoming planetary and space science missions. Professor Bharadwaj naturally has published about 200 peer-reviewed research papers in international journals and various chapters in books, and has supervised several PhD, MTech, MPhil, MSc, BTech students, leaves. Its research findings led to several press releases from NASA, I'm sure including Water on the Moon, okay, that is related to that. European Space Agency, ISRO, cover pages of American and European journals and media highlights. This is very important. He has been the editorial board member of several international journals, member of governing council, member of the governing council of a number of allied research institutions of India, and chairman of many national science committees. Professor Bharadwaj is an elected fellow of all the three national science academies of India and has received recognition at both national and international level, naturally, including two most prestigious science awards, Bengaluru Partner Award in 2007 and Infosys Prize in 2016. Currently, Professor Anil Bharadwaj is a member of the NASI Council, Chairman of the National Committee of INSA, International Science Academy, International Science Council for Postcard and Sports. A person of this eminence has come to JN Planetarium today to speak to us on a very, very important and interesting and exciting topic on Indian lunar missions. So, I thank Professor Anil Bharadwaj for this kind gesture and thank the ASI for facilitating this here in Planetarium and both. So, thank you very much.
Thank you. Thank you, Dr. Visa, for a very generous introduction. And thanks to the Planetarium and ASI for hosting this event. Let me share the slides. Oh, you want to do something? Okay.
Yeah. On behalf of Jawaharlal Nehru Planetarium, Bengaluru, and ASI POEC, we formally invite the Speaker of the Day, Dr. Anil Bharadwaj. So I request our Director, Dr. PRL sir, to hand over an okay and welcome you.
Thank you. Thank you. Thank you. Thank you for the
As a token of gratitude, thank you so much to we present a memento to Dr. Anil Bharadwaj.
Thank you so much. Thank you so much.
Thank you, Professor.
Thank you. So thank you for all this good gesture which you have shown to me, and welcome all the audience to this topic which will take you to a journey of exploration by India of the moon. Okay. This is a very popular level talk. There will be no equations, only pictures and movies. Okay, you can comfortably relax, sit, and listen to this talk. I am coming from PRL, that's called Physical Science Laboratory, which Guru Prasad already introduced to you, and this is one of the oldest institutes of India because it was established by Dr. Begum Sarabhai in the year 1987. At the age of 22, he established PRL just few months after India came. And this institute is also called as the Cradle of Space Science in India because all the activities started. Oh, he's telling me to restrict my movement, eh? Very difficult for me. Okay. So I will introduce PRL by telling that what you're seeing in the bottom are the four campuses of PRL. The main campus, which is in Ahmedabad in Navaranpura, we have a campus, another campus in Ahmedabad, which is called Bharadwaj campus. Then in Udaipur Solar Observatory in Udaipur, which is in the middle of the lake, which is called Fateh Sagar Lake. So those who are interested to do the boating can go to this observatory. And few of my colleagues are there from Udaipur Solar Observatory present over here. And then we have an observatory in Mount Abu, which is a 1.2 and 2.5 meter telescope. And these guys work in the night, and these guys work in the day because they are looking at the sun. They are looking at all the stars and galaxies. So I was mentioning that it was called as Cradle of Space Science in India because all this research in space sciences started under the leadership of Dr. Sarabhai. And that's why when we talk about ballooning program, the rocketry program, the satellite program, everything started under the leadership of Dr. Sarabhai. Here you can see Dr. Kalam along with Dr. Sarabhai and the Malum Nayak, who was later on the ISRO chief. Okay? And the first rocket launch took place from Thumba in the year 1963 on 21st of September. Actually carried experiments which were developed in digital systems. And PRL, which came into existence in 47, did not have a building. So it was working in the house of Dr. Sarabhai. And then we had the foundation laying ceremony in 1952 by whom? Sir C.V. Raman, whom he considered as his guru, and that's why he called his guru to start this laboratory. And then in 54 we had the actual building which is seeing over here in the top, and this was inaugurated by Pandit Nehru that time, the Prime Minister. This is how it looks like now. So anybody is interested to look at this more than 75-year-old building is most welcome to visit here. As I was mentioning, we have two telescopes, one in Mount Abu, other one in Udaipur, and you are also welcome to visit these two observatories which are world class. इसका लाइट ऑफ कर देंगे, पूरा ऑफ कर दीजिए. Yes, ये भी ऑफ कर दीजिए. There is a crater on the moon. ऑफ चाहिए मुझे. ये भी ऑफ नहीं? अच्छा, आपको वीडियो करना. So there is a crater on the moon which is called the Hawaii crater, and this crater is on the near side of the moon. If you have a small telescope, you can actually see this crater because this is about 8 km in diameter and 1.7 km. Now talking about the solar system, before going to the topic of if you look at this, you will see that there are two different classes of planets. One is inner part of the solar system, Mercury, Venus, Earth, and Mars, and then outer part of the solar system, that is Uranus, Jupiter, Saturn, Uranus, and Neptune. So inner part planets are much smaller in size compared to the outer part of the system. They also are called rocky terrestrial planets because they have surfaces to them. The outer planets are called gaseous planets because they don't have surface to them. Okay. In addition, you also have small bodies like asteroids and comets, which is also there in the solar system. Very important for us to understand the whole solar system. So I'll be talking about more into what happens to the Earth moon, which is one of the moon in the inner part of solar system, which is quite big. Venus doesn't have, Mercury doesn't have a moon. Mars has two small satellites, which is called Phobos and Deimos. But if you go to the outer part of the solar system, you have very big satellites. Jupiter has more than 80. The biggest one is Ganymede, and I will show you that. And then there is large number of satellites for Saturn, Uranus, and Neptune. Now talking about how big these sizes are, if you compare, you will say Earth and Mars, Earth and Venus are of same size. Mars is roughly Mercury 1/3. But when you talk about the outer planets, you will see Earth is the 5th largest, right? But how does it compare with Sun? Where is Earth? One small dot, right? Over here. And on this dot, now you imagine India. Inside India, you imagine Bangalore. Inside Bangalore, you imagine Planetarium. And then inside that, a hall. So how big we are with respect to the sun. Okay. Talking about the moons or natural satellites, I was just mentioning that Ganymede is the biggest. Next comes Titan, which is the satellite of Saturn. And our own moon is the 5th largest satellite in the solar system. But look at Mercury or even Pluto. They are smaller than the largest satellite in the solar system. That means we have objects in the solar system which are bigger than the satellite, natural satellites, right? Like Ganymede or Titan. So I am going to focus more on moon and we'll talk on exploration of moon by India. And when we talk about exploration, it comes to the series of missions which India has done. called Chandrayaan. Chandra means moon, Yan means spacecraft. That's how the word Chandrayaan is. And this was coined by Atal Bihari Vajpayee. Earlier we are all calling this mission as Soumya. But he said, ये कुछ जमता नहीं है, इसका तो चंद्रयान. And then he said, Chandrayaan nahi, Chandrayaan 1, because it should have series of missions. That's how this Chandrayaan 1, 2, 3 is. So I will talk about the Chandrayaan 1, Chandrayaan 2, and of course then the most important, the Chandrayaan 3, which we had super landing, and I will show you some of those cases. So starting with the Chandrayaan 1 mission, which was of course a very celebrated mission because it discovered the bottom of the moon. This one is working, hopefully. Okay, not much help. Anyways, so this mission was truly international character because it was a participation by 10 different countries. Yes. And 3 experiments being flown for the first time in the exploration of planetary system. If you want to look at this in more detail, you can see over here. I was directly involved with the SARA experiment, which is sitting over here in the top there. But you also see, oh, this is better? Oh, good. And you also see an independent box which is called Moon Impact Probe, the grey box. And this is the one which was released after we reached the 100 kilometers of orbit to land into the south pole of the moon, very close to the Shakadan. And this made MIP the first main-manned object from India to land. That means we had implanted Indian flag on 14th of November 2008 itself. Right? So about 15 years back itself, we had MIP which landed very close to the. What kind of science has come out? First and foremost, the discovery of water. Till that time, we are thinking moon is bone dry, there is no water on the moon. But now we know water is there on the moon, it is below the surface, it is above the surface. In addition, it also discovered a lot of sciences, including the mini matrosphere of the moon. It validated lunar map hypothesis. It talks about tectonic and volcanic activities of the moon. We were thinking that the moon is dead, geologically dead. No. And there are ample evidences now to suggest that volcanic activity has happened almost like 2 to 10 million years back itself. So moon is not geologically dead. And of course, detailed studies about volcanic vents, which can actually be used for human habitat, which can happen very recent future. And these are the places where you get the natural shield if you want to have a habitat. A lot of science results have come out, 2 of them are shown over here. There are more than 200 scientific publications and peer-reviewed international journals. One is talking about discovery of bottom of the moon, another is talking about discovery of mini matrosphere on the surface of the moon. And if you look at how the surface of the moon looks like, let me see whether you can see this one. Oh, there it's This is how the surface of the moon actually looks like. So moon is actually full of craters. These are all small craters. I will show you big craters later on. And it is craters filled moon of sizes ranging from centimeters to meters to kilometers to 100 to thousands of kilometers. And big craters are called as basins. Like South Pole Alpine Basin we talked about, is a huge crater of more than 100 thousands of kilometers size. So moon is full of craters. Don't compare moon with anybody. Okay, and it also has geologically different surfaces. You see here, it is quite different. That means the composition at that location is quite different compared to the other places. I will quickly jump to Chandrayaan 2, and this was a much more complex mission than Chandrayaan 1 because it also had a lander and a rover. And we had the launch of this in July of 2029. And we all know what happened, right? We could not land successfully on the moon surface on 7th of September. But it validated a lot of technology which was developed for soft landing. Because it reached perfectly well up to 2 kilometers above the moon. Right from the launch, towards soft landing just 2 kilometers above the lunar surface. And that is why a lot of technologies get validated for the soft landing which India was doing for the first time. Nobody in the world gives you such kind of technology. You have to develop a few. And that's why I say that landing itself was a partially successful to an extent of almost 90%. This has orbiter which is functioning for the last 4.5 years. It is still orbiting 100 km circular polar orbit, providing us excellent quality of science. And these 8 experiments on board on Chandrayaan 2 are still working. One of them, which is very important for the Chandrayaan 3 landing, is OHR, which you see the resolution of 25 centimeters is 1 feet. So we can now know the moon in much better way compared to where we are knowing during the Chandrayaan 2 landing. And this experiment, OHRC, was actually used to decide the landing site and to know what location we should choose for the Chandrayaan 3. There is a lot of science which has come out from the Chandrayaan 2. I will not go into detail of that except to tell you that we now have a good understanding of distribution of water on the moon. We have good understanding of argon-40 distribution in the exosphere of the moon, elemental composition from the glass, and the distribution of sodium on the surface. But also about the buried craters, which has come out from the dual frequency SAR experiment. And if you see this SAR image, you will see that actually these are structures where we have buried structures sitting beneath the surface. And this information is also very important if you want to assess how much of what is there on the moon, which is there more in the polar regions. We also have experiment to look at the Venus ionosphere, and also an experiment to look at solar X-rays which is falling on the lunar surface, because the class instrument on the Chandrayaan 2 looks at the elemental composition through X-ray fluorescence technique. But to know abundance, we need to know how much solar X is actually staying on the lunar surface. And I can say that this is the most sophisticated X-ray spectrometer currently operating worldwide. Now I will quickly jump to Chandrayaan 3 and talk about this mission, because this is the most celebrated mission. Here we had a lander module and a propulsion module, because we had Chandrayaan 2 already orbiting. So we don't want another orbit. We only want a vehicle which can carry us to the orbit of the moon. That's why we had a propulsion module. And inside the lander module, we had a rectangle. So lander, that is the Vikram lander, rectangle sitting inside. And we carried experiments on the lander and experiments on the rover. There were 2 experiments on the rover, one developed in PRL, one developed in LEOS in Bengaluru over here. And we had 4 experiments, 3 of them developed within the country. One of them developed in PRL along with the collaboration from SPL and BSSC. Seismometer and Lemma probe is developed in BSSC, and seismometer is developed in LEOS. All these experiments have worked professionally well. I have used the word professionally because we are talking about science. And they have provided excellent quality of science. But landing in the 70 degrees south was for the first time in the country has done. Therefore, all the data which has come from this experiment is for the first time in the history of exploration of the moon. This is how the Shah Shrikota site looks like. You can see here LMP-3. This is the launch vehicle Mark 3 sitting over here just the day before the launch at the launch pad at Shrikota. But if you want to have a closer look of this, you can see this. And this is what we call as the Bahubali of our launch vehicle, series of launch vehicles, because this has a lift of mass 6 tons. We had a fantastic launch on 14th of July 2023, that is last year in the middle of the day. Are you interested to see the launch? देखना है? जोर से आवाज नहीं आया। Sound? Sound? Okay, fine. I think you are able to hear. Oh, fine. Leave. So this was the launch. I was actually there in the mission control. आसमान को चीरते हुए अपनी भयानक दहाड़ से चारों ओर कंपन उत्पन्न कर रहा है। इसे हम यहाँ महसूस कर सकते हैं और यही दहाड़ है जो वैज्ञानिकों को रोमांचित करती है। धीरे के उत्पादन के साथ ही हमारे अंतरिक्ष यान चंद्रयान 3 चंद्रमा की यात्रा प्रारंभ हो चुकी है। So this was the launch. It was just a 1.5 minute thing. There will be 45 minutes launch. Okay, so after the launch, you can see the crowd. Here in Kota, there's so many students who actually come with their parents to watch us. Those who are interested can actually go to the show website and register yourself to witness the launch. Okay, it is open to public. At the Chandrayaan 3, there were more than 20,000 people watching this launch. And this is the one which I like very much, where you see actually the launch with the woman and the kid going to England. So after the launch, we went into orbit around the Earth, went into a lunar transport trajectory so that we can reach the moon, got inserted into orbit, and then came down to 100 kilometers circular orbit. And after that, we went into 100 by 30 kilometers so that we can start descending onto the lunar surface. But before that, we were also testing all the subsystems of the spacecraft. And one of them is over here. Let's see if it works. So this is the lander imager, which was there on the lander, taking all the images. And just 3 days before, we tested all the subsystems of spacecraft to see that they should work very well during the landing. So this is still in orbit. The lander is moving. It has been separated from the propulsion module, working of its own, going in orbit. And now you can see the craters better. But these are still, you will see smaller craters. There are other subsystems on the spacecraft, like LHD tag, which is basically a lander hazard detection and avoidance cameras, because it is an autonomous landing. Everything is decided by the onboard computers, by the images taken by the cameras, fed to the computer and decided. So we have to test all the subsystems in the spacecraft. One of them was this. D-Day, 23rd August. I don't know where you were, but I was certainly there in the mission control, looking at this launch. And you must have seen what was relayed to you, right? So I will try to relive that event for you.
The sensors that are updating at this point are providing confirmation of the safety of the landing site.
As expected, the retargeting is going on, and this is a very good signature for the lander.
So we are all getting this information in the mission control. And the Prime Minister was there in South Africa, watching it live. And this is actually a simulation, okay? This is not actual. In the last minute, there are only 2 engines which are working. You will see sometimes the small thrusters. So it started landing like this, but then finally land has become vertical and do vertical landing. Okay? So it has become almost vertical now. You see vertical descent is happening. And there was a provision for hovering. Suppose it finds that the place is not good because there are too many craters for the landing stage. So it has to hover and find the best place in that.
Who is here to encourage us, and he is critically looking at the visuals.
Because Indians are shut off.
People are
पूरी तरह से सेफली और सॉफ्टली चंद्रमा की सतह पे लैंड हो चुका है, ये हम लोगों के लिए बहुत ही गर्व की बात है। हिंदी में एक कहावत है कि चंदा मामा दूध के, लेकिन अब हम ये कह सकते हैं कि चंदा मामा अपने घर।
So India became the fourth country in the world to have the landing on the moon, but the first country to do the landing very close to the sun at 70 degrees. Okay. This all you must have seen, but what we are seeing in the mission control. This is the continuous information fed by the lander imager into the mission control about how active the lander is with respect to the landing site. Now you can see different sizes of locators, because this movie is also just 1.5 minutes. So we are very close to the surface, somewhere around 150 to 200 meters above. And very soon you will see this image is becoming still, that means the lander has become almost vertical. And then it is actually started descending. But before that, there was a retarget. Just keep on watching, these are all craters. And remember that we are actually landing towards. We are landing in the morning hours at the landing site. Lunar day is 14 Earth day, right? We have to work for 14 Earth day there, when the sunlight is there at the landing site. So this is early 6:30 in the morning. We are landing at the landing site. Therefore, the crater's shadows, one sided will be completely dark, because it is the green sun which is coming and hitting these areas. Very soon you will see this whole area will become stagnant, sort of moving. That means the lander has become almost vertical and started descending down. The big crater has just passed by. See all these different sizes of the craters. We are just very close to the lunar surface now. Maybe another 50 meters or 40 meters. So this information was actually live relayed into the mission control, and we were actually looking at this. See this stability. And it is found on the side, and it started descending down. And it's going down, 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 landed. So we were relying more on this because this is the live image which is coming during the landing. And that gave us perfect confidence that we have landed very safe. So we are all over the moon. I was also celebrating with the module of Chandrayaan lander and Pragyan rover. But how was the world celebrated?
India has done it. It has become now the fourth country to land a spacecraft on the moon after the US and China and the former Soviet Union. Just moments ago, our target.
India has made space history, becoming the first nation to self-land a spacecraft on the moon's south pole.
India has become the first nation to successfully land a spacecraft near the South Pole of the Moon. Countries here, Brenda Logan has praised the achievement, saying that the mission's success belongs to all of humanity.
The spacecraft Chandrayaan-3 is attempting to be one of the first to land on the moon's south pole.
India is the first country in the world to land a spacecraft near the moon's south pole. A moment of history for the country. It was at tense 5 or 6 minutes as it descended onto the lunar surface. Let's show you the moment. First of all, let's take a seat and see us.
Celebrating the successful landing of
What part was the spacecraft?
Okay, now India's lunar probe Chandrayaan-3 has landed on the moon's south pole. India is the first country to touch down on this part of the moon, which is believed to hold promise.
We begin with some historic news. India has become the first country in the world to successfully land a craft near the moon's south pole. Prime Minister Narendra Modi was watching the mission from South Africa and congratulated the team back home. Let's take a closer look at what.
So the whole world was celebrating, we were all celebrating, but then in the mission control, we had to do the next job. And next job is to bring out the Pragyan rover onto the lunar surface because it is sitting inside. We have done all the testings in the lab, but now we have to do onto the lunar surface. So now you will see how actually the rover came out. For the rover to come out, there was a ramp which has to be deployed, and then only the rover has to move down. So the most important event was the ramp deployment, and you will see a movie of that. Because if RAM is not deployed, rover cannot come out. See, we have landed, this is the lab, this is the RAM now getting deployed. And this is the first image which we saw of the rover sitting on the RAM. And this was actually a very delightful moment because immediately after that we have the what is called the formation, the solar panel deployment activity, because all activity on the rover and the lander is depending upon the sunlight. If the solar panel is not deployed properly, the rover cannot work, right? So this was the most important activity. And after that, we said, okay, everything is fine. We can go ahead and release the rover to land onto the lunar surface. So now what you are going to see is the first small step which India has taken in form of rover landing or rolling out into the lunar surface. This is the rover. Started released, going down. You see the shadow on the rover, this side. That is sunlight is coming from this side, right? And I was watching very closely, and this was the time I was holding myself like this. You know why? Because there was a crater. And I said, Baba, the JB has landed just now. It should not go into the crater. So we were all working out to see whether this crater is big enough for or small enough for it to roll out. We found yes, it is possible. And then this rover actually passed. You see the track, right? And it moved out of this small rover crater, which was there just in the front when it landed. Subsequent to that, there was a lot of movement, and you will see how the rover started playing. Oops. See this crater here, moving very slowly. Rotating. Now it is almost perpendicular to sunlight so that it can generate power. Power was very important for all of us because any activity on the lunar surface has to be dealt with the power, and therefore we have to always see that solar panel of the rover is always at 90 degree to solar illumination. Remember, all this is happening on the moon, commanding through Bangalore Control Center. After this initial movement, we found that the camera on the rover is seeing a big crater, right? And we said, Baba, ab to nahi hoga. It cannot pass this. We have to trace back the rover and go to the other direction. So we move back. This is the back trace from the rover, because rover has two in the front and one in the back camera for it to navigate well. And all this was fed live into the mission control. We used to decide what action is to be taken, and then the rover movement has to be done. All the movies which you are seeing now is actually an action of few hours. But you are seeing in 1 minute. Okay? And the most important of this is the Vikram lander onto the lunar surface. This is an image which is probably the image of decade for India. That Vikram lander sitting on the lunar 70 degrees south, imaged by the Pragyan. Or you can see it much better over here at the edges. So this is a very near picture, this is a far picture. And see the sky is dark, right? You must have heard about that, no? On the moon when automatic, oh, the sky is dark, it's not because there is no atmosphere, right? And you can see also the experiments which were deployed onto the lunar surface. One of them is Charles, which was actually deployed to measure the temperature up to a depth of 10. And there is a seismometer which is sitting over here. This was to measure the seismicity of the landing site. How was the rover playing around? See how was the toy again playing on the surface. This is several hour movie, eh? Don't believe it was doing this. So we will always see at final position when the experiments have to be conducted, because it has to be staging condition for the experiment. It has to be perpendicular to the surface so that solar panels can charge the batteries. So this rover made a path which is shown over here. It moved almost like more than 100 meters onto the surface. And if you look at this, the landing site which we call as Shiv Shakti as the landing site, we went into this direction, found this big crater, came back, went into this direction, came back. We said no. Why? Because there were scientists sitting in action deciding which site we should go, because this crater which you were here was believed to be a fresh crater. Therefore, we are interested to see what we are going to see near the fresh craters. So finally, the Brigham lander is sitting at the Shiv Shakti point, and the rover is sitting at this point at the. After we were accomplishing almost everything, we said, okay, let us do one more. This was not planned. This was called hop test. Hop test means you lift the lander from the surface and just land somewhere. We found that sufficient fuel is available. We can do that with the ample amount of fuel present, because we don't want to have complete fuel. This is essential because tomorrow we have to return back to the surface. The engines have to fire after 10 days or 15 days of the landing. And therefore this test was done in the middle of the night of 2nd September, when we found that everything is working very well. And the mission is ending because after a few days there will be dark at the end. So what you will see actually is a hop test, again taken by the lander imager, of how this happened. You will see a lot of dust coming out when the engines are firing. And then it just landed almost 2 feet away from that. So this is now the rollback. This was the track you must have seen. This is the place it was moving. Engines have started firing. Completely filling with this. You will see very soon. You won't see anything. Complete firing of the engines. Nothing is visible, and it has come back. It landed just very close to the landing site. If you remember what you were seeing earlier, now this was a very important test, because sample return mission do in the future, we have to do this. After that, we again deployed the RAM. You see here. So everything was redone again, just to test that we have this capability which exists with us with respect to survival on the surface of the Earth. In addition to this, of course, all the 6 experiments which were there, 5 of them on the rover and the lander, and 1 on the pressure model, has worked very well. They have provided excellent quality of science data. You see here chart, this has given us the temperature profile beneath the surface. Ramba LP has actually talked about the charged particle distribution close to the landing site. ILSA was actually able to see or sense the rover movement. So whenever rover was moving, they are able to see the signatures in the ILSA. LIPS is looking at the elemental composition of the lunar surface as well as alpha particle accelerometer. And both of them have provided us excellent quality of science data to look at what is present at the 70 degrees south. Is it different than what has been seen by Apollo, or the sample returns vision from the Moon? And we do find differences. A lot of work is being done to understand. This is just the preliminary science data which you're seeing over here, but scientists are still working on looking at this data much more carefully, and not only that, yet they have to do a lot of simulations in the lab as well as theoretical simulations. So that is being carried out, but I can very confidently say that the quality of the science is going to come out is going to be very, very unique. The propulsion module, which has taken Chandrayaan 3 into an orbit about the moon, was still orbiting along with the Chandrayaan 2. And this continued for several months. Finally, is that if we have to do sample return missions, let us see whether we can return this propulsion module back to the orbit of the Earth. And that was exercised so that we can move this propulsion module back. You will see over here, we do a deorbiting. We came closer to the Earth. This is in the orbit of the Earth. And now it is orbiting Earth. And this is also very important because this is the one more step closer to sample return missions, which we have to do in the future. Therefore, now this is orbiting around Earth, not around Moon. We have brought back from the orbit of Earth. Little bit about future of what we are planning to do. I think another 5 minutes.
Sure.
So, what we plan to do in the future? Chandrayaan 1, Chandrayaan 2, Chandrayaan 3, so there has to be Chandrayaan 4, Chandrayaan 5, Chandrayaan 6, right? But each will be very, very different. One of them, which we are working with the Japanese scientists, or ISRO, that's the corporation, is to do landing very close to the polar regions and go into deep shadowed regions, which is called permanently shadowed regions, where sunlight never reaches. Why? Because Moon is spinning on its axis almost vertical. Earth is tilted 23.5 degrees, right? This is how it goes around the sun. But Moon is vertical. So if we have craters in the polar regions, they will never see the sunlight. Okay? But most of the craters may see the sunlight. Our idea is actually to go and land at those locations where you see sunlight throughout. Very close by, you have a crater which doesn't see the sunlight. Because we want to see what is there in this permanently shadowed regions and what kind of volatiles, because if temperatures are so low, pressure is not there. If any volatile, including water, goes and sits there, it will be like a deep freezer, minus 200 degrees centigrade, minus 250 degrees centigrade. And therefore, we want to know what is there inside. That's why this mission is being planned. The idea is to have the launcher and the rover from Japan, but the lander will be from India. And this will be about 3 to 6 month mission, where you will go inside the deep shadow regions, come back using a rover, charge again the battery, go down, make observation, come back. And the lander will be the one which will be used for relaying all the science data, that similar to what we did in the Chandrayaan, because the Pragyan rover was feeding the data to the Vikram lander, and Vikram lander was in communication with the Earth. So this is the important mission, and this will be again precursor to ISRO's Lunar satellite. Our idea is now we have shown orbiting, landing, rovering. So what is next? We should bring something back from the Moon. That's why we are participating in this mission, because this is going to be very useful for us for sample missions. What more we are planning to do, you must have heard about in the newspapers, Prime Minister talking about that we should have a Bharatiya Antariksha station and also landing of human to the surface. There is a series of experiments which need to be conducted for achieving this, because it is not very easy. There are a lot of technology which has to be developed for achieving this kind of missions. But ISRO is known for doing this, right? And that's why the target has been given by the Honorable Minister that in future exploration we should target to have the Antarctic station, which is again going to be a media for us to do orbiting of the Moon from the station, or bringing humans back to Earth using the space station. The space station is going to be a stepping stone in terms of technological development, but also it will be very, very useful when we talk about human landing onto the moon somewhere around 2040. In addition, of course, there are a lot of other missions which is being planned, for example, future exploration of Venus, Mars, and things like that, because in the Mars orbiter mission, we have achieved the orbiting. Now the idea is to do landing on Mars. But landing on Mars is not simple as because there is an atmosphere of carbon dioxide. So now the technology which is required there is different compared to that which doesn't have an atmosphere, right? So these activities are in progress. We are working into this to see that we get first a sample return mission and then going for human landing on the. So thank you all for listening patiently, and I'm delighted to be here at this planetarium as a part of the ASA participant. But also thank Guru Prasad, my friend and colleague, for 3 decades for stressing on me that you have to come. Thank you.
And it's, if you have a question and you want to ask in Kannada, you can help me to translate it to.
मेरे को कन्नड़ा नहीं आता है आपको ट्रांसलेट करना है.
So don't hesitate. Right? Either in Kannada or English.
और हिंदी चलेगा, थोड़ा बहुत गुजराती भी चलेगा.
Sir, good evening. Thank you very much for a very wonderful and informative talk. And I am Professor Vijay Kumar Garbane, teacher of Anil also here. What about the magnetic field experiments? Was there any experiment of that kind, magnetic field measurements kind of thing were done?
There was no magnetic field experiment on Chandrayaan 3 or Chandrayaan 2, but in the future, yes, we plan to carry a magnetometer on board. Actually, Moon doesn't have a global magnetic field like us. Okay? There are pockets of magnetic fields, and which we have seen in the Chandrayaan 1. When I talk about discovery of mini magnetosphere on the Moon, where there was an instrument called SARA, which was actually having sensing the protection of neutral hydrogen from the lunar surface, which comes because of the interaction of the impacting source. Indirectly, we are sensing the magnetic field, right? But it was not a magnetometer which was doing it. It was a instrument which is looking for signatures where the solar wind is not able to impact because of the formation of mini magnetosphere. Like in the case of Earth, we have a huge magnetosphere, right? And because of which we are saved because of this high energy charged particle which is coming towards Earth. But Moon doesn't have. Everything comes and hits the lunar surface.
And this compositional analysis results, any preliminary results, solar abundance or anything deviating from solar abundance?
No, you must have seen this one.
Yeah, I saw it. Yeah.
Right. Yes. So this is what is there in the public domain. There's more which is happening, which I cannot reveal right now because it is under embargo by the PIs, the instruments. So unless they give me permission to show, I cannot.
Thank you. Thank you very much.
There are many theories how these remnant magnetic fields are there. Are there remnant magnetic fields? Are they produced because of impact of some bodies, like impact magnetizations? Or are they left out of the global magnetic field which are there on the Moon? Because we are talking about the lunar magma hypothesis. In the case of Earth, we have a molten, and any moving charged particle gets magnetic field. So molten core is actually producing magnetic field for the Earth. But in case of Moon, we now know that more or less everything is solidified. And therefore, you don't have that kind of magnetic field formation in the case of Moon.
Local magnetic field at a particular area, maybe due to some mineral content in the area, iron or cobalt.
Yes, that is possible. But then how did it happen? Issue is how did it happen? And why there only? It is not just the iron is there, so you will have made it. No, it's not. It has to be a process. Yeah, go ahead, go ahead.
Moon, because it has an atmosphere of CO2. Why is it so, sir? And what are all the problems we are going to
Okay.
face landing on Moon?
Now you imagine that there's an aircraft going with no atmosphere. Can it happen? No, right? Because the aircraft needs air to be moved around its blade for it to fly. Right? So when you are doing a landing on an airless body and landing on an airy body, the technology has to be different. Simple being, there will be a lot of heat which will be produced when you are passing through an atmosphere. And this heat also has to be taken into account. For example, I will tell you, when we return back from space, comes back like space shuttles, or we are talking about the Gaganyaan mission. We are talking about heat produces on the envelope of the capsule which is carrying animals. Why it is happening? Because at Earth has an atmosphere. And therefore the heating produces a plasma. And the temperature is so high, it can actually last the whole capsule. So heat has to be taken out immediately. And that's why there are special carbon foils which is produced on tiles, which simply burns out and take out the heat, so that the heat doesn't go inside. Right? So the technology required for landing in an airy bodies has to be different. It may also help you because it is an atmosphere which will do a retardation. Then heat is there. Use this. Yes. Okay. As I mentioned to you, Chandrayaan 2 was not a failure. Chandrayaan 2 paved the path for the Chandrayaan 3. Chandrayaan 2 orbiter is working very well, still working, providing a successful orbit. Lander technologies were demonstrated by the Chandrayaan 2 lander. But it did not do soft landing, right? And there are reasons behind it. So what we did in Chandrayaan 3 was we strengthened the base. We reduced, instead of 5 engines, we took 4 engines. We increased the landing site so that we can do a perfect landing. And there was a lot of other changes which is done inside the spacecraft or the lander, so that we get a good information about the activities when the landing is actually. But this has to be simulated on the ground. And therefore, there were a lot of tests which was carried out, actually the simulation conditions of how the lander will behave in landing happens. Because it is autonomous landing. There is no command control given from the space, from the ground. Okay. Now talking about the craters, right? Since moon doesn't have an atmosphere, any object which is coming towards the moon will produce a crater. Whether it's a small object or a bigger object. So crater on the moon is nothing but an effect of any body coming and hitting. Okay? And that's why you're seeing craters of all possible dimensions. Small object, small crater. Bigger object, bigger crater. Crater के अंदर crater, crater के बाहर crater. इधर crater, उधर crater, जिधर देखो उधर crater ही crater, right? हिंदी समझ में आया? नहीं आया? Everywhere crater is there. Craters inside craters, craters outside craters. There are craters in the walls of the craters, right? So any object coming in hitting will produce it, which is not happening on Earth. Why? Because we have an atmosphere. So our magnetic field and our atmosphere is actually a big shield for the planet.
Hello sir, my name is Anil. I just wanted to know that the solar interaction with the lunar surface, does it affect our satellites also?
Solar interaction with the lunar surface, meaning solar electromagnetic radiation or solar particle radiation? Particle radiations. Satellite generally will not get affected by this kind of process because if you are moving in a higher orbit, like 100 kilometers, 80 kilometers, you don't see much impact. But if you are sitting on the lunar surface, yes, you may see a kind of plasma which is produced very close to the spacecraft and which may have some disturbances when you are doing communication. We did saw some signature of that in the landing.
Okay, I just wanted to know that basically there is a term called horizon flow and streamer. That the lunar surface there is a dust clocking near the T9 terminator. So when the hop-up was done, so basically I think that it would have activated the whatever elements that are present on a lunar surface. So can it basically affect it in a more way with the satellites because electrons are getting ejected? So can it basically create some impacts?
There are two ways in which this kind of effect can be looked at. One is visual, basically dust. Okay, so you saw that when the hot test was conducted, you see completely dusty when the engines are completely firing, and just after landing everything became white, as if nothing has happened. That means dust is not a big issue. Okay? If dust is not a big issue, that means there may be minuscule amount of plasma there which is not visible. But that can only be seen if you are able to really discern that. Currently, we did not get much disturbances because of that. And that is why this was one of the tests which we are trying to see when we really do a lift off from the landing. Because lift off is different than landing. Right? Here you are coming down, and after that nothing. If you don't reduce your velocity to zero, it will crash. Now here, the infinite space available for you. Launching is easier than landing.
Very interesting. I'm just educated with this basic formal education, but out of curiosity, I keep looking at it and my kids. My one question was, we need to rotate the entire that rover towards the sun perpendicular. Can't we make it such a movie that it always faces the sun and then this can take any direction? That is rotated means.
So you want to give more autonomy to the rover, self-driven, AI, artificial intelligence on a rover which is running on its own. It is possible. It is possible.
We always end up there and
But then the problem would be that if you are doing an experiment, AI will overrule that. जैसे हो गया तुम्हारा काम चलो अभी हमको मूव करना है, right? So we want it to be under control, and it is not that if small angle will create any issue, but whenever we are parking this rover and doing experiment, we want to ensure that maximum power is generated. Maximum power is generated when you are at an angle. That was
it was the cost factor that was very well discussed at the international arena, that what India can spend and what we are capable of. And when we continue to do such things, will be much more affordable and very economical and other things, which was not covered in if we could cover all that, because there are a lot of other private companies already doing a lot of X, Elon Musk and other people are already doing a lot of things in space.
So where do we stand when a private entity is doing it, and when other so advanced countries are not been able to do this? What was the economical factor that we can await? And we are only the fourth country, so there are a lot of hundreds of countries who are awaiting our technology and maybe the cost factor, economical benefits.
I can only say that it was much cheaper. I cannot give you numbers because such things are not available in any domain. It is cheaper because the way you function. If you must have seen, when we did the launch, we went around Earth for some time. Then we went into a trajectory towards the moon, and then we orbited around the moon for some time. This was a way of optimization. I don't want to spend a lot of fuel in going directly from Earth to moon. So we have seen Russian mission. No, slow nahi hai. It is not called slow. It is a way to design your trajectory. Okay? And there are a lot of scope for you to do any corrections if you need to, right? Which is not possible if you are just going straight away to the moon. You can go in 2 or 3 days. Right? But then the cost is very high. Okay? So you have to optimize everything. And you have to look for the success. So there are a lot of other things which are not telling you now. We already have an experiment which is looking at the charged particles around the moon. One of them will actually look for charged dust. Nothing bad.
So, sir, you said that during the vertical landing, Vikram lander was analyzing the surface so that no crater or less crater will come in between lander and surface. So, apart from the camera that you were showing the video, were there any other system who was analyzing the?
Yes. There were 5 different sensors. Okay. And all of them were feeding the information on the software, on the computer, on the lander. Acceleration, velocity, images, horizontal velocity, vertical acceleration, horizontal acceleration, and where you are. So that's why I just showed you LHDAC, which is lander horizontal velocity information which is fed inside. We tested all of them before landing, but we did a lot of tests on the Earth. There is a space called Cheragiri, which is close to Bengaluru, where artificial craters were created. The lander was allowed to land autonomously. Looking at different craters, deciding which is the best place for me to land. Okay.
Sir, just one more question from my curiosity. You said Udaipur Solar Observatory is observing sun. So, what primary focus of observation is of Mount Abu telescope? What is the primary focus of observation?
Mount Abu telescope looks at the objects in the sky in the night. They look at comets, they look at planets, they look at exoplanets. In fact, I can tell you now that the first exoplanet discovered in the country is from Mount Abu telescope, where we use the PRL instrument, which is developed for the first time within the country. And this exoplanet discovery was hailed by the Prime Minister Modi ji himself by tweeting it in 2018. And subsequent to that, we have discovered 2 more exoplanets. They are all discovered using Mount.
Thank you so much.
Any other questions?
Sir,
So, that's it. Over now. Number of questions are increasing. Maybe can we limit it to another few definitions in that few. If moon comes closer to Earth, moon is receding away from Earth, you know. Actually,
Moon is receding away from Earth at a speed of about a centimeter every year, and Earth is slowing down. So probably after some centuries, 24 hours will not be 24 hours. Because you must have heard about tides, right? Lunar tides. स्कूल में क्लासेस में पढ़ाते होंगे, राइट? लूनर टाइड्स, ज्वार भाटा जिसको बोलते हैं हिंदी में, राइट? They are all caused by the moon. Solar tides because of sun, lunar tides because of the moon, right? Because Earth has the fluid of water, its tides are much more dominant. They control the planet Earth. It is not that moon is obeying Earth. Moon is actually controlling Earth. Right? So it is very unlikely that moon will come closer to Earth. Moon is likely to recede away. Unless and until there is another body which comes and brings moon closer.
Hi sir, my name is Kavya. So you were like, you said that Chandrayana 4 has a rover in it which will go into dark place and come back. When it goes and when it comes back, it is possible that when it goes and come back again, it will go right, sir. In dark space, it is possible.
There is a surface. Okay. There will be a lot of study which will be conducted before that fellow goes down. Okay. So we have observations on radar, which is called as on the Chandrayaan 2 itself, looking at these permanent anomalies. Oh, I showed you some of those pictures which you must not notice it. And they are going to give us a lot of information about what kind of surface we are going to extract. It is not going to be slip. Okay, ऐसा नहीं है कि स्ट्रोक पे आया slip हो गया चला आया. So it is not going to happen because it will be a slightly different. I don't know whether it is here. Oops. I don't know whether I can see this. It's not there. So fine. So there are a lot of technology which is conducted to see that on the slope also it doesn't slip. Okay? And once you give a command that you have to be there for this much time, it will be there for that much time. Because that also is to be charged because you need sunlight. And for sunlight it will come out. Right? So they will program the thing with respect to how long you can be there. You can be a few hours, you can be a day. Do your science, come back. Let yourself charge, go back. Yeah? जैसे क्रिकेट में होता है ना, रेस्ट करो थोड़ा, उसके बाद फिर चार्ज फिर बैटिंग चलो, right? So that's why the tea break, lunch breaks, right?
Yes.
So my question is, so the mission, with the one with the JAXA, so we are going to explore the regions which will be shadowed. So I just wanted you, if you can shed the light on the spectroscopic instrument, and according to you, just your intuition, do you expect the bindings of element to differ greatly from the shadow region and the unshadow region?
We still have not good idea about elemental composition in the formation. Okay? Simple reason being, fluorescence spectroscopy, which is depending upon photons coming after reflecting from the surface, is not because no photon is going there. Either you have to carry a photon source and over there and see what is there. It is not. Okay. But radars have given us a lot of information about what kind of material is present there, how deep, how much water is present there, what kind of mixing ratio of water is there to day. And that has given us clues about the volatiles, because we are actually looking for volatiles, and water is one of them. We know now water, it is there. How much quantity is there? And what is it different than in the sunlit regions, completely sunlit? But remember that moon also has a day and night. बहुत लोगों को ये कंफ्यूजन होता है कि मून में डे होता है नाइट नहीं होती है, नाइट होती है डे नहीं होती। सो मून हैज a day and night like that. It is 14 days day, 14 days night. Okay, the last. फिलहाल तुम्हारी जिंदगी में कुछ नहीं होने वाला, डोंट वरी, ओके? In your lifetime, nothing is going to happen, okay? So take it easy, enjoy your life, do well in your studies, and become one of those who can land on the moon, okay?
Just a minute. The questions that were asked actually shows how good it was. Formally, to thank everybody here and also the speaker, I request my colleague Ms. Lakshmi to give a vote of thanks.
Okay, now I can sit down. Okay, thank you. This card here can be.
Very good evening to everyone. I deem it a privilege and a great honor to propose vote of thanks on this memorable recognition of 42nd Anniversary of PSI. First and foremost, I would like to thank the speaker, Dr. Anil, Dr. PRL, for making time I thank the entire team of PSI, IISc, ISRO, and of course Team JAP for putting all the efforts and making all the required arrangements to make this venture a successful one. I extend my heartfelt thanks to the audience, both offline and online, for attending this talk and asking so many interesting questions and making the session a very interactive one. It's you people who made the process so. Once again, I thank one and all. Thank you.
Tomorrow we have a third lecture, third public lecture. It is on the sun through the eyes of India's Aditya album, and the speaker is Durgesh Patil from Ayuta. The venue is the same auditorium, and the talk will be at 4:30. 4:30. So please, I request one and all to attend tomorrow's talk, and hope today's talk was very enjoyable, and it will be on all the remaining lectures. So please attend all the lectures and enjoy the astronomy through this week. Thank you very much.